Well, hello everyone again. Here we are with 1.1. So we're getting into the Algebra 2 book now. Starting with Chapter 1, Section 1. And in this section we're looking at parent functions for, I'm going to kind of do a broad parent function, and then we're going to specifically look at 4 of them in this lesson, and then start to understand what transformations are. We'll look at those. Those are kind of more of the vocabulary that you're going to need to write down. And I want to focus a little bit more as we start to graph these, because we are going to be doing graphing of these functions, to do graphs with table of values. So I'm going to kind of use this lesson to look at how to graph with a table of values. All right, but first, before we get into all of that, let's go ahead and look at a little quick cartoon. So here's an in the bleachers. And the announcer's saying, the outfielder is going back, way too far back. He's almost about ready to go off the cliff. It's a long fly ball. All right, well, let's get into our first section here, looking at parent function. Okay, so this is a broad view of all the parent functions that we're going to be looking at in Algebra 2. Now, I highlighted the ones specifically that we are going to be doing in this lesson. Everything else is going to be coming kind of further down the road in the next few chapters. Even when we get into semester 2, we'll be looking at some of these other ones. But it kind of gives you definitely the name of the function is here. So this one's linear, this one's absolute value. It does tell you the equation of that parent function, y equals x, y equals absolute value of x on this paper. So I'll get you this paper here. I could probably have it on your Google Classroom or a hard copy of it. But it's a good, just a reference sheet for all the different functions. And the parent functions are the functions that are the original functions, like where we start from. All the other functions we do kind of come off of these. So you got to think of functions kind of more in terms of a family. So this is the parent of the linear. And there's obviously a whole lot of different lines we can draw, right? We can draw down, negative slope lines this way. We can draw other positive slope ones going this way. That'll be different than this line, but the original would be this line of just y equals x. The most basic one is what a parent function is. And so that's why I've highlighted those, but you can see on this one all the different ones we're going to be doing in Algebra 2. So as we look specifically now at the first 4. Okay, so on this core concept and also in your notes, there on page 4 in the notes, it says parent function for the first one. You want to write this down, that a parent function is the most basic function in a family. Remember we talked about we got to think of functions as a family. And so each function has a name, like you have the Smith family, the Garcia family, those kind of things. They have the family name. Well, you have the constant family, you have the linear family, the absolute value family, the quadratic family. That's the family's name. The parent is the most basic one of the family, and that's going to be given to you as a rule or an equation, like in here it shows you that. But on page 4, where it's giving you the vocabulary, go ahead and write down this part right here, just that the function, it's the most basic function in the family. Functions in the same family are called transformations of their parent function, and we're going to look at what those are in just a minute. But make sure you understand this here as far as the rule for each one of these 4. The most basic one for the quadratic is just x squared. So anytime you see a square, the variable being squared or x being squared, that's a quadratic family. You have the absolute value signs on this. That's what these lines are for. These are called the absolute value signs. So this is the absolute value family. This one's just x by itself. If it's just an x, then it's a linear family. If nothing's happening to x, it's not being squared, there's no absolute value signs. There's nothing else going on with the x. It's not underneath the square root sign or anything like that. If it's just plain x, it's linear. And if it's just a number, if f of x equals a number, then it's going to be a constant. That's that horizontal line where there is no slope. Or I should not say no slope, but the slope would be 0. So you got to realize also, another thing you might think about, what this f of x is talking about is the same thing as y. So this means the same thing as y. We talked about that in the function little review. But when you see f of x, that just means y equals x, absolute value of x, and so on. And we also talked about what domain and range was before in that function lesson. And here we see it again. Every time we talk about functions, we're going to talk about domain and range. And so remember, domain is just the x-coordinates of these functions, and the range is the y-coordinates. You want to write that down again. So domain is talking about the x-coordinates or the x-axis. Range is the y or the y-axis. I always remember x comes before y, d comes before r for domain and range. And so when it's asking you what's the domain of this function, now these are not discrete, right? These are not just points, these are continuous functions with the lines. They have the arrows in the end, they can keep going forever in both directions. So you can see that the domain for every single one of these functions is all the same, it's all real numbers, because it's everywhere on the x-axis. And remember, that's really what these are asking you. It's asking you where is the graph on each axis, so where is the graph on the x-axis for domain, where is the graph on the y-axis for the range. And so for this one, the domain is everywhere, so that's all real numbers. Another way you could also say all real numbers, and you can use the infinity symbols, sideways 8, negative infinity, comma, positive infinity. This would be called an interval notation here, which is kind of like an ordered pair. But it goes from one end to the other, from this number to this number, so from negative infinity to positive infinity. That's what that would be considered. So the linear one is all real numbers as well. It's all real numbers for both, in fact, because it's everywhere on the y-axis as well. This one is only at 1, because it says the constant function here is at 1. So it's only there at 1. This one is all real numbers because left and right, it's going everywhere this direction, everywhere that direction. But as far as up and down, it's not below the x-axis. It's only above. So it's only above 0. So it's going to be an inequality of y is greater than or equal to 0. So y is greater than or equal to 0 is that one. It's the same for this one as well, because you can see it's only going above 0. It's touching 0 because it does touch the origin there, but it only stays above the x-axis. So y is greater than or equal to 0 for the range. The domain, again, is all real numbers, negative infinity to positive infinity. This is where this is going to go. Remember, this is just a little window, but since the arrows keep fanning out further and further left and right, it's going to go everywhere left, everywhere right. And so that's domain of all real numbers. Okay, so we're going to go on to page 4 and look at these other vocabulary words. This is now transformations. So the word transformation, just write this down, that it changes size, shape, position, and orientation of the graph. So you have your parent function, the transformation is going to change something about that. So as you add more numbers in, like if you have a slope number of 2, that's going to change something about it. If you have a y-intercept, that's going to change its place, its position on the graph. So there's going to be a transformation. Now, different transformations have different words. There's actually really 4 different ones you can see right below the word transformation. You'll see on your page 4 it says translation, reflection, and then you have vertical stretch and vertical shrink. So you have a stretch and a shrink. Those are the 4 different types of transformations. Let's first look at translation. So translation, and write this down, is a transformation that shifts the graph horizontally or vertically, but does not change its size, shape, or orientation. It's only going to change its position. So this translation is all about position. Where is it going to be positioned? So as you change, the position of this graph right here, g of x equals x minus 4. Remember, our original one would just be x. It's got now a number here, negative 4 for the y-intercept. So you can see there's the original right there in black. There's the y equals x, or f of x equals x. Your new one now changed position. It moved down 4 units. Still the same slope, okay? It's still the same slope because the transformation is only going to change its position. By changing the slope, that would change something else that's not a translation. So slope would not be a translation. Only changing the y-intercept there, putting a y-intercept on that graph is going to change its position. Let's look at the next word, which is reflection. So reflection, you want to write this down, is a transformation that flips a graph over a line called the line of reflection. Now that line of reflection could be the x-axis, or it could be the y-axis, or it could just be some other line. It's possible, but the most common ones that are going to be used is the x-axis and the y-axis. So as we look at like this graph here, it's a quadratic graph. You see the x is being squared. It's got a negative in front of this. So the parent function, we'll see here, let's look at it, is in black. There's our parent function. And our new function is flipping over the x-axis because there's a negative sign there. So how do we know that there's going to be a reflection? Well, we're going to see it's going to be multiplied by a negative. That's the difference there. So you have your parent function, x squared. Now it's negative x squared. That's going to flip it into a reflection. So when you're multiplying your function by a negative, it's going to flip it over the x-axis here. Let's look at the next word, which is the stretching and the shrinking. In fact, let me back this up one more. Okay, so I cleaned this up a little bit now. So stretching and shrinking uses the word vertical. We're going to use the word horizontal eventually as well, but let's just not worry about that just yet. But let's just worry about what stretch and shrink are. Really, that's what you want to kind of look at in this lesson, is just getting used to those two words, stretch and shrink. So a stretch would be when the factor is greater than 1. So when the factor is greater than 1, the transformation is called a vertical stretch. Let's keep the word vertical in front of there, but it's definitely a stretch. And when the factor is greater than 0 and less than 1, so basically the numbers between 0 and 1, like a 1/2 or a 2/3 or something, then it's a vertical shrink, or it could be like a 0.4 or something like that. So we need to realize that these numbers here, the factor numbers, are the numbers that are going to be multiplying. It's like your slope number, the number that's in front of the x. It's the number that's in front of the absolute value sign. It's the number that's in front of the x squared number. So it's something that's going to be multiplying. So you're definitely going to be multiplying by a number to get these stretching and shrinkings happening in your equation. So if that number, if your slope number is greater than 1, like if it's 2 or 3, you're going to have a stretch, vertical stretch. But if your slope number is like a 1/2 or 2/3, it's going to be a shrink. It's going to be a vertical shrink. And this kind of gives you the imagery of what happens here. A stretch is basically going to get thinner or narrower. So when you're stretching it, you're going to do this here. It's going to kind of become this red one here. So if it starts off at the blue one, you're stretching that. You're going to be making it narrower or thinner. And if you're going to shrink it, that's going to be like this one here, where it's going to get flatter or wider. So if you start off with the blue one and you were to shrink, it's going to go down to this red one and get wider. That will shrink it. So that's what's going to happen to your graph. It's going to stretch, it's going to get thinner or narrower, or if it shrinks, it's going to get flatter or wider, like closer to being a straight line, in fact, a horizontal line. Now, there's also some other things we might want to look at as well in here, and I'm going to put this also in, I want to make sure that's very clear. This is going to be in the next lesson mainly, but I'll just take a look at it real quick right now, which is a graphable form of the absolute value as well as the graphable form of the quadratic. Is the same thing, but we have an A, H, and K, and you're going to start to getting used to this A, H, and K. A would actually that's where it's the stretching and the shrinking. So when you see that number, there's a number there, it's being multiplied. That could be like your slope number on a linear one. The A is going to change the shape. So that's going to be your stretching or shrinking. And A also could be negative, which would make it flip and be a reflection. So this A could be two things. It could be the stretching or the shrinking, or the A could be a reflection. The H and the K, those two are for translations. The H would move it left or right, or right or left. It's going to move it horizontally. H even can stand for horizontal. And the K is going to be moving it up or down on the y-axis. And both of those are going to be your translation ones. So the translation has these two things. These two numbers would refer to translations, just moving it and shifting its position. But this number in front actually has all the other transformations attached to it. If it's negative, it would be the reflection. If it's at some number other than 1, well, then it's a stretch or a shrink. Depending on if it's a stretch, that number would be like 2, 3, or greater than 1. Or if it's a shrink, it's a number between 0 and 1, like a 1/2, something like that. All right, let's move on to the next. Okay, on page 5 on our extra practice, we want to do a few things to these problems here, 1 through 4. So identify the function family. So what's the family's name? Compare the graph to the graph of its parent function. So number one, we'll look at this one. We can obviously identify that's a straight line. It's going to be a linear function. It's a y equals mx plus b equation. So you're going to write linear for this one. But I want you to also graph the parent function. So there's definitely some patterns with these parent functions. For the linear function, remember, is y equals x. That's our parent function. And so basically your slope would be, or your y-intercept of this would be 0. There is no y-intercept, so it's going to always go through the origin right there. And the slope is 1, so it's going to rise 1, run 1. So it's always going to be right there, that line going through 1, 1, 2, 2, 3, 3, and so on. So it'll look like that. So it's going to go through the origin, 1, 1, 2, 2, negative 1, negative 1. The number x and y are the same. X equals y. So all the ordered pairs of this will always be the same. 1 and 1, 2 and 2, and so on. That's your parent function. Now as we compare it to this function here, you can see there's three things actually going on here. The first thing you might want to notice is that there's a negative. You have a slope number here. That slope is negative, which is going to cause a reflection in the x-axis. That slope number also you can see is a fraction, which is less than 1. It's between 0 and 1, so it's a shrink. So that 1/4 would tell you that's a vertical shrink. And it also has a y-intercept number of 8, so it moved positions. So that's going to shift up 8 units. That's a translation shifting up 8 units. So you can see it's going to be something like this. You can write it down either way, the way I wrote it up here, or you can write it like this as well. It definitely is linear. You want to say linear, but then you can write the rest of the stuff as well. Now the domain and the range of these are all real numbers. That's another thing you want to write for this. It doesn't necessarily say that, but that's the way we can compare it. The domain and range of each function is all real numbers. It does have the same domain and range. Linear functions are always going to be all real numbers because it's going to go everywhere left, everywhere right for the domain, everywhere up, everywhere down for the range. All right, number 2, you can see it's a horizontal line. That's going to be a constant function. And remember, our parent graph for the constant function is just y equals 1. So if we were to graph that, we would just draw a horizontal line through 1 right there on the y-axis. That's our parent function. So the only thing that happened here is that it moved down, down to -3, which actually moves it down 4 units. So you can see the range on this one is changed. That's one thing that has changed. The range for this was, remember, y equals 1. But now the range is y equals -3. The domain is still the same. The domain is still everywhere, all real numbers left and right. Another thing that you can see has changed. It shifted down 4 units. So there's the differences between the parent function and our new function. So again, we write the word constant, and you can talk about the translation 4 units down. The domain of each is all real numbers, but the range is now y equals 3, where the parent function was the y equals 1. All right, let's go on to the next two. Okay, number 3 we notice is a v-shaped function. So just remember v for value. So this would be absolute value. So v for value is that one. And you can always also see the absolute value signs right here on the function on the equation. So you know it's an absolute value function. Remember, the parent function for the absolute value is just absolute value of x. Now there's an easy way to graph these parent functions, especially for these two here. This absolute value one, it's always going to start at 0, 0, so it starts at the origin. And then when you put in 1 for x, you're going to get 1. So the absolute value of 1 is 1, so it's going to be 1, 1. If you put in -1, you're also going to get 1 because the absolute value of -1 is also positive 1. So it's going to go 1, 1, -1, positive 1. And so it starts to do the same thing. It has the same kind of idea going up one direction, up the other direction. That's why you see it as a V. So here's what the graph would look like right there. Now notice this is going by 2's though, right? There's 2, 4, 6, 8. So my 1, 1 would be here, -1 would be there. If I put in 2, I'm going to get 2. The absolute value of 2 is 2. So we go 2, up 2. If you put in -2, you're also going to go up positive 2 because you put -2 inside here, absolute value of -2 is positive 2. And so you graph this one direction here, which is kind of like one arrow, one ray, and the other one going here, making this v function. That's always what the parent function does. So you can kind of go one to the right, one up, one to the left, one up, and that's all you really need because you already have your v shape with that. So you just really need those 3 points on an absolute value function to go ahead and graph it because you're going to graph a v. Now what else might be a little bit different here? Well, you notice the 5 in front of this. That's going to change something there. So what's it going to do? It's going to stretch it. It's more than 1. So that number is a stretching number because of it being more than 1. So it's a vertical stretch. The domain and range, I should say the domain is the same for both. They're all real numbers because it's everywhere left, everywhere right. But the range actually is the same as well. So it still has the same range because you could see it starts at 0, 0 still. That did not change. So it's y is greater than or equal to 0. So you want to write that down as well. For number 4, this one you can see is a U shape. The U shape is the quadratic function. So we make sure we write that down as quadratic. And the parent function, remember, is y equals just the x squared. There's an easy way to graph this one as well. You start off at 0, 0 again. You always have a starting point for these. So 0, 0 is your starting point. And as you put in 1, you're going to get 1. 1 squared is 1. Negative 1 squared is also going to be 1 because negative 1 times negative 1. So you're doing the same kind of thing so far as we did here, but you have to do more than just the 3 because you're not going to get a v here. Quadratic is going to be a u. Notice if you do, you'll have a 1, 1 here and a negative 1, negative 1, just like we did over here. But when we go to 2, that's where it changes. Remember over here it was 2, 2. Look at what's going to be here. When I go to 2 and I plug 2 in, 2 squared, what's 2 squared? That's 4. So we're going to go 2 and then go up 4. See how that's different? With this one, it was just 2, 2, and now we're 2, 4. So now you can see what it'll look like there. So there's my 1 point, but then 2, 4 going there. When I go to 3, right here, 3 squared is 9. I got to go all the way up to 9. We're going to do the same thing on the other side because as I square a negative, that's going to change it to positive. So that's why negative 1 is positive 1. Negative 2 is positive 4. So it's going to do the same thing on both sides here. These are symmetrical with the y-axis being the axis of symmetry of that. Now this has more going on than just the x squared for our new function here. As you can see, we have a 1 here and a 4 here. So that's going to be our translation numbers. Remember, your stretching, shrinking, and reflection number is always in front, like where this 5 is. That's always stretching, shrinking, and reflection number. But the numbers in here, the one that's inside with x, is a translation number, and the number here, 4, is also a translation number. So that's going to change things. One thing we know we did change here is that the range also changed. It moved up. It's no longer y is greater than 0. It's now up here at 4, because there is the highest or the lowest point of this now is at 4. It also shifted right 1 unit and up 4 units. So that's another thing it did that's different. That's your translation. So you can either write it down the way I kind of wrote it here. This is what's different between these two as we look at it. Use the word quadratic. Make sure you name it quadratic for this one. Talks about the translation. There's the 1 unit right, 4 units up. Talks about the domain is still all real numbers, but the range has changed to y is greater than or equal to 4. And the range of the original one was y equals greater than or equal to 0. So make sure you understand that, understand why those are that way. That's where the graph is on the y-axis for the range. The graph on the x-axis is everywhere to the right, everywhere to the left, even though on this window it kind of looks like it stops where the arrows are, but the arrows would just keep going and going left and right to infinity. So remember, those arrows mean infinity to the right and to the left. All right, let's move on to number 5. Okay, so from 5 to 10, it says graph the function and its parent function. So we want to put both on here and describe the transformation. So for number 5, this is a linear function. So we want to make sure we understand which of these, what are these here. So we have 5 is linear. 6, you can see, it's just this equaling a number, that's a constant. And then number 7 has an absolute value around the x, that's an absolute value function then. And so we know what they're going to look like. This is going to be a V shape, this is going to be a straight line, this is going to be a horizontal flat line on number 6. So for number 5, our parent function for 5, remember, is just y equals x. And so that's just going to go through 0, 0, And remember, it's going to be like 1, 1, 2, 2, 3, 3. It's just going to keep going up along this way, down this way as well. So you just need to put 2 points really and draw a line. You can put one here at 0, 0 and at 2, 2, and then draw your line from that. That's the parent function. Make sure it's an easy one to graph. Now for this one, -7 is our y-intercept. So just like we've done those before, you're going to put that on the graph first, just with the slope and the y-intercept. So plot that down here at -7, and our slope, rise over run, is 1. Slope is 1. So remember, that's like 1 over 1, because you want to see it as a fraction of rise over run. You're going to rise 1 and run 1. So if we rise 1 and we run 1, that puts us right about there. So let's put a point right here now. And then you can just use your straight edge to go ahead and graph that line as well. Now these lines, since the slope did not change, as you can see here, it's still 1 like it was here. You can see those lines are parallel. They're parallel lines when the slope is the same. So as far as describing the transformation for this one, we want to say right here that the graph of f is a translation 7 units down. So make sure you write this as well as far as describing the transformation. That it's a translation. Use that word, translation, because it moved positions. So it has a translation of 7 units down. You got to say how many units and which direction it went. So it went down 7 units, something like that. Number 6. So remember, our parent function on this one is just y equals 1. We can put that right here. Remember, this is going by 2's now. Notice that. So 1 is right here. So we can go straight, flat line right through 1 right there. And this one is at -9. So we want to go down to -9. There's -8. -9 is right below that. We're going to put a point maybe right there at -9 and then draw a straight flat line through there. So there's that one. These are easy to graph. And what would the transformation be now? So for this one, the graph of f is a translation. So again, we're using the word translation. 10 units down. Notice all of these are translations so far. 5 and 6 and 7 will be that as well. So it's just looking at the translations of these graphs. So we're using the translation word. 10 units down. It went from 1 down to -9. So that's why it's 10 units down. For this one, remember, our parent graph is just the absolute value of x. And so that's going to be, remember, the easy way to graph that, start at 0, 0. Then you can go 1, 1. If you want to go 2, 2, you can. Or you can go to -1, +1, -2, +2. It's a V shape right there. It's always the same. So it just has that same pattern for the parent function. Easy to graph. So make sure you just graph that V for the parent function. And now as far as this one's concerned, it has the same shape, notice. Only thing it did is it moved up 1. So this +1 right here shows you it's going to move up 1 unit. Now another way you could do this is with a table of values. And so here's what I'll have you do. I'll have you go ahead and write this table of values down here with an x and a y. So our x numbers we're going to choose is we're going to plug in 0, we're going to plug in 1, we're going to plug in -1 in for x. Those are our input numbers. I want you to get 3 output numbers as well, and then go ahead and graph the V shape that should be inside here. So go ahead and pause the video and do that, and then play it again to check your answer. Okay, hopefully you did this already. You got the 3 numbers over here for the Y, the outputs, and so those numbers right there, so 0, 1, when you plug in 0 here, it's going to be 0, which will just leave you with the 1. When you plug in 1, that's going to be 2, because absolute value of 1 is 1, and then it will just give you 2. You plug in -1, you're also going to get 2. And so when you start with putting in on these points, 0, 1 would go right there, just right above the origin. 1, 2, and -1, 2 will go on each side of that. And now you have a V shape with these 3 points, and you just want to go ahead and draw your V shape. It should be inside that parent function. So as far as this one, the translation, again, we're going to use that translation word. It's translation 1 unit up. So make sure you write that down for this one. It's absolute value function, translation 1 unit up from the parent function. All right, our joke of the day. Why is it so hot in a football stadium after a game? All the fans have left. Aha. Okay, so we're on page 6 now, 8, 9, and 10. So So we're going to do the same thing on these ones. We're going to graph these. We're going to graph the parent function. We'll do that first. Notice the type of functions we have here, 8 and 9, are both quadratic ones. You can see the x squareds, and number 10 is an absolute value one. So we want to graph the parent function and then graph the actual function we see here, and then go ahead and compare those two. So remember that this one, the parent function for the quadratics for both of these, would be y equals just the x squared. And so let's put on this one here, we're going to start off with 0, 0. It's always going to be our starting point. And then we're going to go 1 to the right and 1 up, 1 to the left and 1 up, because when you plug in 1, you're going to get 1. When you plug in -1, you also get 1. And then when you go to 2, you're going to go up 4. So you're going to see 2, 4, because 2 squared is 4, -2 squared is also 4, and that gives you the curve that you need. So that's all you really need. Those 5 points should be enough to get you the curve you need for your quadratic function, which is called a parabola. In fact, this actually has a special name called a parabola. The graph is called the parabola. It's a quadratic function. That's still the family name, but if we actually want to give the graph a name itself, we can call it a parabola. So you're going to hear that word sometimes come up. As far as now this function goes, well, we want to do a table of values for this. So I'm going to have you stop the video and plug these numbers into here and see what numbers you get out. So these are your input numbers, get your output numbers, and then go ahead and plot the points on here that you get. And then you can make sure, I give you 3 numbers. Now you need 5, of course. I give you all positives. Just make them negative as well as you plug them in, and you'll see where they go. But you need 5 points. Go ahead and stop the video and try to get the graph on here now from this table of values. Okay, so hopefully you did that, and now you're going to plug in 0. You should have gotten 0, so that's still going to be 0, 0. Point can go right there. And you're going to plug in 1. So 1 squared, you got to do the square first, then multiply by negative. So 1 squared is 1, and then it becomes a -1. And so it's going to be -1. So if you go 1 to the right, you're going to go 1 down. If you go 1 to the left, you're also going to go 1 down, because -1 is going to be the same thing as +1 does. And then 2 and -2 would actually be the same as well. So if we plug in 2, we're going to get 4, but it's going to go down to -4. And so now we can see our graph here. We got 0, 0, and there's our points right there going down 1 unit. So left and right 1, we're going to go down 1. And then left and right 2, we're going to go down 4. That's what that's going to do. So that's what the reflection does. It just flips all those points upside down, and now you can just draw your curve going down with the arrows going down. As far as the comparison now, the comparison would just be it's a reflection in the x-axis. There's a reflection in the x-axis, so that's what happens here. So the only difference, though, we might also want to notice is that the range does change as well. So right here, the range of this would be greater than or equal to 0. Y would be. Y is now less than or equal to 0 on the blue one. All right, when you come to 9, let's go ahead and put our parent function down. Go ahead and graph that yourself. Go ahead and pause the video, graph this parent function, do it again, just like this one, and then play it again. Okay, so hopefully you put your parent function down on this, which would just be the y equals x squared. So that's going to be your origin, the 1, 1, and -1, 1, 2, 2, and then, I should say 2, 4, and then -2, 4. And then you're going to go ahead and graph it. So there's your parent function. And now for this one, we're going to use a table of values. Here we're going to use 0, 2, and 4. So again, whatever we do on one side, the same is going to happen to the other side. So go ahead and graph these, find these numbers here, plug them into this. 1/8 is you're going to multiply it afterwards. So square the number first, then multiply by 1/8 to get your outputs. And then go ahead and plot those points. And you'll see half of the graph, the other side is going to do the same thing. So go ahead and do that right now, pause the video, and then play again once you've got your other graph down, this 1/8 x squared. Alright, so if you plug in 0 to this, you're going to see basically 0 times 1/8 is still going to be 0, so you still have an origin point, 0, 0. If you plug in 2, that's going to be 4, and then 1/8 times 4 is going to be 4/8, because you see 1 times 4 is 4 on top. 4/8 would reduce down to a 1/2, so 2 and a 1/2 point. And then if you plug in 4 squared is 16, we're going to see 16 over 8, which is actually just going to give us 2. So as you start to plot those, you put a 0, 0 again, same thing there. But then we're going to see 2 2 and a 1/2. So if you go over to 2, you're going to go up to 1/2, which is just a little bit up. You do the same thing going this way. Go to -2, you're going to go 1/2 up. 4 and 2, so we go over to 4, go up 2, you're going to do the same thing if you go to -4. It's going to give you the same result going up to +2. And then we can just go ahead and graph that. Notice that it moved down. It actually shrank because it gets closer to, went from the blue one to the red one. It went down, it shrank, it got wider or flattened out. So we were going to talk about a shrink on this one. So it's going to be a vertical shrink we want to talk about there by really a factor of 1/8. Notice the factor number is less than 1. It's between 0 and 1. Number 10, absolute value function. Remember, our absolute value function is y equals x. I'll give you a minute there. Go ahead and pause the video and draw this parent function on this graph. Okay, hopefully you drew that. We did this already on the last couple problems before when we had absolute value functions. So you're going to go ahead and just graph the absolute value function, your V shape. It should look like that. At 0, 0, there's your starting point. And then you got this, 2, 2, your -2, 2. That's all you needed was just to graph the V. And then now we see this 6 here. It's a number in front. It's going to change the shape. In fact, we could talk about this already as being a stretch. It's going to stretch it because it's more than 1. So let's go ahead and do a table of values again. And once you get used to it, you can always graph with a table of values. But you do want to be kind of strategic about the numbers you pick for your inputs. And we're going to pick 0, 1, and -1. That's a -1 on this one. 0, 1, and -1. Go ahead and pause the video, plug them into here, and see what you get, and then draw those points down here, plot them, and then draw your V shape. Okay, hopefully you got your other V-shaped function of 6 times the absolute value of x. So that's going to end up being 0, 0 when you plug in 0. When you plug in 1, that's going to give you just a 6. When you plug in -1, the absolute value of -1 is still 1, and 6 times 1 is still 6. So when you have 0, 0, that's going to be right there at the origin, but then as you go to 1, you're going to go up 6. -1, you also go up 6. So it's a very narrow V. So as you make your V shape, it's a very narrow V shape right there. It's inside this other one. So you can see, yes, it definitely did stretch by a factor of 6. So that's what we want to say down here. You want to notice it says it's vertical stretch. You want to say that for this one. And you could say by a factor of 6, because that's more than 1. It's going to stretch it. Okay, we just have a couple more problems. It's number 11, identify the function family here. Describe the domain and range. Use graphing calculator to verify your answer. So just the function family, we could see the absolute value symbols. We know definitely from that, that's a dead giveaway, that it's an absolute value function. So write that down. And as far as the domain and the range, you might want to look at the graph, and so you can go to a graphing calculator to do this. It says verify with the graphing calculator. So we could do that on the Desmos graphing calculator. If you're not familiar with that, you can always go to just website here, or just a search, and just type in desmos.com. So just Desmos, it's already there, .com, and it says start graphing. So here's your start graphing, and now you have a graphing calculator. And we can just type in our function right here. There's a place down here where it's got a little keyboard, so you can kind of get this keypad going here. And so you can put in what you want. Now we need an absolute value function, so that's why we want to hit the function button over here. But it starts off, let's see, how does it start? 1/3? Yeah, so it's got 1/3. You can put f of x, you could put y, or you could just put this in here. You don't even have to put this equals. So we could start with the 1/3, in fact, and I'll put 1 divided by 3. That starts off with the 1/3 there. And then we need to put our function in. It's just the miscellaneous over here. Let's see. No, that's not it. Nope, never mind. It's not the functions. There it is. Absolute value of a. That's what we want. So there they are, right there on the keypad. So we want to plug in, what did it say, -x inside here? Yeah, -x. So we just put a negative and an x in there. Whoops, that's not what I wanted to do either. Let's go ahead and back that up here. We want to put this inside. There we go. So -x goes inside there, and then at the end of this, what did it say at the end? +4. So we're going to put our +4 at the end, and then there's our V-shaped function right there. So it wants us to know the domain and the range. Well, the domain is still the same it's all real numbers. It's going everywhere to the right. It's going to go everywhere to the left. As you can see here, as this keeps getting bigger, bigger, it just keeps going to the right. It keeps going to the left. Doesn't stop there. So that's why the domain is all real numbers for the domain left and right. Where's the graph on the x-axis is what that's asking you. So we can write over here on our page that domain is all real numbers. And as far as the range goes, so the range, it's you can see our point there, which is called the vertex of this. That's the corner point. That's going to be right at 4, so it's only above 4, which means it's greater than or equal to 4. And so that's what we want to write there for the range. Range is y is greater than or equal to 4. Okay, so that's how we can see that. All right, let's move on to the last one, number 12. Okay, so number 12 says the table shows the distance a biker rides in his first team relay competition. So this table, again, is just a table of values like we've been doing. It's just kind of done horizontally. So here's your x numbers, 1, 2, 3, 4, and your y numbers here. First question says, what type of function can you use to model the data? And you might think, okay, I'm not sure what function this is. It's got to be one of the 4 we've been talking about: linear, constant, absolute value, or quadratic. So what we could do is we can go ahead and plot these points. We not only notice that they're all positive, so instead of drawing a x and y axis, we can just draw what we call an L graph. Actually, I put linear down here. It is linear, and let's see why I would do that. An L graph would show us that it's linear. So that's just all your positive quadrant, right? Quadrant number 1 right here would just show us this. And so we want to put some marks down here. I just put 1, 2, 3 marks to put in our 1, 2, and 3 for the hours. So x is about the hours, so 1 hour, 2 hour, 3 hours. And then the distance here is the y, so we're going to put the marks up on top here. So I'm putting these spacing these a little further apart. So 12 miles, 24 miles, 36 miles. And then I'm just going to plot a couple of them. So at 1 we're going to be at 12, and at 3 we're going to be at 36. And you can just draw your line from there. It's going to be, at 2 you're at 24. You're seeing it, it's all lining up. 4 you're at 48. So this is all going to line up. That's why it shows you that this is definitely going to be a linear function. So that's how you can definitely tell that. Now it says if the biker's teammate rides at the same pace but leaves 1 hour later, what type of transformation does this represent? So he's leaving 1 hour later instead of leaving at hour 0 like our biker's doing, and in 1 hour he's already ridden 12 miles. Our biker, or his biker's teammate, leaves at hour 1. So if he leaves right there at hour 1, but he's going to ride at the same pace. So that pace would still be the pace that he's doing, which is really looks like 12 miles per hour. So every hour he's going to do 12. So he's going to, if he's going to ride, 12 miles in 1 hour at 2, he's going to be up at 12 right here. And so we could put a point right there and notice that's going to be a parallel function to this. So what changed from the biker to his teammate is just a translation, right? It just shifted. It just moved right 1 unit. So it's a translation that would represent that transformation. All right, so that concludes our 1.1. You want to go on to the assignment for 1.1, and I will see you on the next lesson.